Hi, everyone. We are about defense, and we will make a presentation about Mexico's cybersecurity status. During this presentation, we will talk around industrial cybersecurity footprint, key data, perspective, smart production, and sensor security experience, Honeypot, lesson learned, and opportunities. Thank you, ICI Village, DEFCON 28, and the Cyber College on this opportunity to make a presentation about Mexico industrial cybersecurity. Talking about Mexico facts and figures. We have, in facts and figures, in terms of the economy, Mexico is ranking on the position 12 around the world. Manufacturing services, transportation, utilities, and spending are the main economical activities in Mexico. In concern of industrial sector, the manufacturing has an activity of 175 billion US dollars. Key subject focus on IC industrial security for this presentation. The top industrial sectors are in Mexico, the automotive industry. It's the top 5 world with OEMs and their supply chain. Medical is the second position in Latin America, behind Brazil. Aeronautics 60% more competitive, and electronics the third largest economical region worldwide. Also, Mexico have other industries like oil, electricity, food, textiles, agriculture, chemical services, consumers, and furniture, among other sectors. On the industrial sectors, more are important that the main manufacturing companies use 55% of insulated PLCs inside the IC area. Most are insulated and most not connected to any network. 3% of use industrial servers at the shop floor and connected to the network. Most of these industrial servers are set by the automotive international companies like from Germany or Japan, among other ones. Most of the industrial companies are located from the center to the north of Mexico. As an example, the automotive industry is located from the center and the north of Mexico. In the case of the aerospace and medical industries are situated on the northwest of Mexico. On the network subjects, we will see that the strongest future is based more in the north of Mexico. South of Mexico is more agriculture and other topics. Mexico have around 50.3 million IP address, an average of 7.5 megabits, and the cyber attacks around 28 from 195 countries. So basically, the most important in the case of the cyber attacks is mainly attacks to the government offices and other departments like banks and services. In terms of the SWOT, the ICS Security, the strength is that Mexico is growing in the industry 1.0. It's focused to the smart production, smart logistics, smart enterprises, among other ones, which require in a short period of time the implementation of the industrial cybersecurity practices. For the US, Mexico, Canada trade, which was released the 1st of July 2020, covered the topic on digital and cybersecurity rules and process between the countries. It's a major important thing because, especially for Mexico, because Mexico needs to follow up and implement the good practices and lessons necessary to accomplish the digital security and internet policies from this trade. In terms of the weakness, Mexico has no deep knowledge on ICS security topics. Also, the companies and the owners had no idea, even awareness about industrial cybersecurity. For those insecure systems, there are insufficient information. There are opportunities as well. The US, Mexico, Canada trade is focused to increase commercial and competitiveness region against other markets, Asian markets or European markets. These trades include the specific actions to meet cybersecurity terms as the first one. Trade, according to our experience, the most attack to industrial is related to ransomware, especially on the ERP systems, as well as the internal attacks is not recorded at this time. Based on the automotive industrial sector, Mexico are located American companies, as well European and Japanese companies, which are located on the supplier chain. The European most used the industrial cybersecurity architecture according with the ISO and the improved and performance basis 4.0. The merits of the concept are the data in real time and non-real time, the integration and sharing data and connectivity. For the American enterprises, they follow the American industry internal reference architecture, call it IIRA. They use it as a key merits, real time, no real time, integration, shared data, and connectivity. But as well, they use the protocols, boost protocols like a Profiboost, Modboost, Scan, Internet, Profinet, and the programs like a Ladder and other devices with different kind of protocols, which is one of the important things to use for industrial architecture cybersecurity. According with our experience during the last couple of years, we implemented for the industrial sector and the architecture different kind of layers. One of the layers is the sensor integrity that we will see in the next slides, the equipment, the bus data, and the network. The word industrial is in terms of the smart factories at this time, using Industry 4.0 concept. They set the connectivity between machines and PLCs and other intelligent sensors, as well other equipment. So the smart factory is integrated all the elements in the shop floor integrated in one unit. To accomplish and fulfill the strategy, we set a smart production concept. This smart production concept is accomplished to fulfill the strategy that we set for the smart production. The smart production is set in individual modules which are interconnected to the smart factory. This architecture integrates components from machines, sensors, PLC, network, servers, database, machine learning, machine-to-machine, analytics, visualization, and artificial intelligence, among other technology and innovations. For a clean implementation, it was a set additional smart sensors to boost the power and the brains at the shop floor to implement the full smart production. That is the new trend. On later slide, we will talk about the smart sensor cybersecurity. One important note on this activity that I want to share with you as experience is the synchronization and speed process key factor for industrial cybersecurity. It means low timing on industrial process is not a problem, as we can use and save the cybersecurity procedures. High speed industrial process, which required up and down information to act, for example, a valve or open a sector or review a motor, less than 500 milliseconds make a major complexity to implement a smart factory with industrial cybersecurity. Also, the lesson learned about the synchronization topic give it two strategies recommendation in according with our experience. One refers to set the PLC responsibility as it was designed at a long time, means that the devices was to control dedicated process and machines, only that. We not recommended that the PLC is doing extended activities. That means doing everything. So everybody can say that the PLC and share and tell you that the PLC make everything. This is not true. This is a dangerous situation. The second one is to reduce or eliminate PLC connectivity into an industrial bus network. That means that the PLC has to do his own job. One is concerned, of course, if we put the PLC on the network, is to reduce the potential vulnerability. And the second one is to reduce the issue on the synchronization on the process and the bus network. One of the topics to confirm that we have experience that is difficult to set a cybersecurity, industrial cybersecurity. For the smart sensors and cybersecurity strategy that we set as 6, no? Which means the S is a sensor, the I is integrity, the C is for connectivity, and the S for this security. This concept that we are implemented, we use it, we divide it in 3 blocks. One is related to the sensor integrity, the sensor connectivity, and the sensor cybersecurity as mentioned. The sensor integrity includes physical and functionality layers. The physical take the sensor damage, which is common sometimes that people can damage during the process at the shop floor, or could be not intentional to damage the sensor. So the cybersecurity protection tells us that the damage is made on the sensor, and then we have to be replaced or make an action immediately. Also, the cycle life of the sensor is important because the cycle life of the sensor, when the sensor is used by a resistance to review and sense the level of the water, they can be changed immediately when we see that the response of the information is not quite right. So we're using this information and review as a status control loop to be that the cycle life of the sensor is okay. Actually, as well, in terms of the functionality, the views of the sensor, as well the software, the program, there are main key important things. The software and the program, they can be used, or that could be as well adopted in terms of the somebody can have and connected with our RC235 or another bus communication, they can make it and change the software and the program. We as well, we set on this strategy as it, the actions and the roadblocks on the firewall that nobody can change the software and the program. In terms of the sensor connectivity, everybody knows. Profibus, Modbus, so this topic I will not to be in detail. And the subject of sensor cybersecurity, the status control gives us also the opportunity to review that the physical and functionality the sensor is okay. Also, self-detection and self-assessment is provide as well that the system, as well the protocols of the software program and communication are okay. We put in outside on this process the cryptography code, because according with the mentioned in the last slides, the synchronization on the latency of the process in terms of the high performance processes is not quite okay. We set as well an additional alert console. That means that this process, the alert console process, we set a different boost communication. It's not in the same protocol that we send it as the information data sent it to the system. It's sending in another channel, and as well another kind of information, which that tells us exactly if the sensor integrity, physical and functionality is abducted. In terms of the essential of the sensor cybersecurity, is shown in really two blocks. Three blocks. One is outside of the system, which is the data interface. The other ones are connected. The detection search, which is called on the left block now, we call it a dummy because this is essential just one thermopar or just a resistance that they move according to the level of the water. We call it a dummy sensor. It is dummy sensor connected via an I2C protocol. This protocol has 4 modes. The standard mode is usually with a speed of 0.1 megabits per second. The information is digitalized and then used to perform the program with a specific language. The program with this has an algorithm and make the action and perform the activities that which was programmed. One of them is to send the information via standard protocol to outside of the world, which means that to send the information to the PLC of the Modbus or another kind of communication to the data interface, which is important because the different kind of net protocols, it was difficult to make a cybersecurity performance. That means that the experience that we have is that synchronization is a very key factor. One topic is in reference of the I2C protocol. Sensing information in some process is a critical element, especially with the high performance process. Process with production and security information can be lost information, only because the process of the boost communication synchronization is not aligned with the process synchronization. And the PLC, if it has a timer and a timing delay, if it's possible to miss key information of the process. That means on the case that latency less than 500 milliseconds and using a crypto code on this communication can be put in an endangered situation the entire system. So we solve this issue using new security paths in the entire architecture. It is clear that integrate a crypto code, as we know from the sensor to outside to the boost node, is not feasible according to our experience today, based on the total boost and the process synchronization. Both things are important and important to do the cybersecurity, industrial cybersecurity. activities. The opportunities that we have in ICS Cybersecurity is in terms of the monitoring. Monitor the sensor integrity as we saw, the equipment safely, and the boost security as main architecture visibility and center management. Defense detections in terms of the boost protocol and the peripheral devices evaluation, the threat detection as a sensor and equipment, the malicious code as well, the prevention as the incident response and services, and as well the equipment risk assessment, which means to review the peripheral devices, the service equipment, and the network devices. During this process, in terms of the IC industrial cybersecurity opportunities, we set a deception exercise. We set a honeypot, lesson learned, and the training that my friend and colleague of this entire venture, which with Alfonso as well, we will see in the next presentation from Victor.
Well, guys, thank you for your time. I'm glad to be here. And well, as you know, there are many experiments and previous publications about honeypots. We apply it for this work on two areas that could be joined in a small footprint. I mean, a small footprint to detect internal events and incidents. Well, the first one is the training, to learn core concepts from previous incidents and learn beyond buzzwords and clickbait cybersecurity news, because we think that this could be overwhelming for many of us. The second one is to be productive. I mean, to get productive data that allow us to have enough evidence to resolve an incident. To implement this, there are previous conditions, previous steps that are important to be known by the network owners, like a correct network installation, a legal review, and patents to see results focused on ICS systems versus general malware. The honeypots as idea and philosophy is very attractive because it's a good way to see an attack in real time, and well, you can learn from it, and also helps to replicate previous attacks. In some moments, cybersecurity could be overwhelming for some people. There are too much to learn, but based on previous attacks that we saw, there are core concepts that could be studied. These concepts are covered by the major corporation matrices, and this gave us a structured way to do it. And the second one is, well, how to handle incident. This could be learned too. And also the ICS architecture concepts are important to give a general path. And finally, the idea of this experiment or honeypot is that could be installed by power users and not only by cybersecurity people. Learning through analyzing attacks, well, obviously is the first option, but there is another game. Honeypot could give productive data in a traceable way. There are three main sources to start. The first one, the Windows host from the multiple layers of the ICS and enterprise network. The second one, the network in the different layers too. And finally, the emulation of the services. And well, all of this in the internal network. The first component in our architecture is the Windows host that are being used in different layers. We looked for simple components and tricks that could give us important data about malware. And well, with this setup, we got multiple samples. For example, with the file system trick, we got multiple samples. And also from the network traffic, we observed that the most popular wormhole ports are being used too. And now, regarding lateral movement and ransomware cases, we saw that the biggest and easiest exploits are being used as first option. From the network side, the another component in the architecture, our idea is to keep all the metadata possible as first priority. and the raw data from the multiple sites as second objective. This could be achieved using SIG and Moloch, these open source tools. But to implement these tools, the Malcolm project helped us a lot to make a quick setup in a productive environment. With this setup, we were able to investigate multiple network movements from the multiple layers of the network, and also to detect dual home PCs. About the DMZ, as I mentioned in the first slides, our idea is to make an investigation in the internal network. However, as you know, the DMZ setup was analyzed multiple times in previous investigations. And as you know, the detection is very noisy and also is a high risk. So for that reason, we focus on internal networks. But some setups was exposed in a short time using Mexican IPs. And there are two important details that worth to be mentioned. The first one is the timing of the attack. There is a correlation between the exposition of the IP on a network passive sensing service versus non-indexed IPs. And finally, there is a gain if multiple protocols are being used instead of only one. And well, finally, to mimic services, a simple setup was performed too on these four sites. The first one is the network emulation. With this, we found that there are many pieces of software that allows you to emulate any port, to replicate any port and copy this kind of behavior. The second one is about the file servers on the shop floor. For this, the use of Honey files were the option. And for the web replication from the front-end web admin consoles, we used Social Engineer Toolkit and also HTTP track. And well, finally, the most important component is Honeypot. As you know, Honeypot is a very popular piece of software to deploy honeypots. And we use this with some physical components. And to make a quick setup for the power users, we use Teapot as a main platform. With this, the use of Teapot was the fastest way to make an implementation by the power users. And well, that's it, guys. Thank you for your time. As a remarks, we saw these points. The USMCA trade is an opportunity to improve the cybersecurity. The second one, well, Mexico is an undiscovered market for the ICS cybersecurity. As Octavio mentioned, there are good numbers that prove this. Also, there is an opportunity to train people in this topic. In all the industrial networks, we found that there are a lot of talented people that could learn in a very fast way, and there is passionate about this. The Honeypot technology and the use of the ATTCQ matrix for ICS as part of formal training and threat detection is a good trick too. And finally, the speed of the network is not a speed of the process, talking about cybersecurity. And well, thank you for your time. If you have questions, please drop us a line. We will be on the ICS Village Discord channel. So thank you for your time and have a good day. Thank you.